Okay, we're starting section 7.2. I'm going to go ahead and let you guys label this. So this is going to be your right triangle trigonometry. And so the first thing we need to talk about is what's a right triangle, right? And then how are our trig functions related to a right triangle. So let's do the right triangle part first. All right, so one of the ways that you can tell right away that you have a right triangle here is the little box there. And the box indicates how many degrees? 90. We talked about that. You guys remember 90 or 90 degrees. Or we could say what? Pi over 2 in radians. Does that make sense to you guys? All right, and then we have, let me go ahead and I'll go ahead and label this because we're going to use it anyway. So then you have, we'll call this A, and we'll call this B, and we'll call this C. Now, A and B are called the legs of the triangle, and C is called the hypotenuse. I'm going to go ahead and put some, I think, an angle into coordinate. Now, you can put your angle in different spots. You're not going to usually use the 90 degrees. There's two places you could put your angle up here. It's a little awkward, but you can put your angle there. Or you could put your angle right here. That's the more classic way to put it, but you'll wind up using it both ways. So I just want to make sure you're okay either way. One thing I want you all to note about the angle theta is it's what we call an acute angle. And when we say an acute angle, we mean theta is between 0 and 90 degrees. And so if you think about that for a second, there's 0, there's 90, correct? That means we're talking about what? Quadrant 1. All right, so when you think of an acute angle, think quadrant 1. It's got to be something in quadrant 1 because you're not including the quadrantal at 0 and you're not including the quadrantal at what? 90. Do you guys see it? Or you could write it like this. Theta's between 0 and what? Pi over 2 if you want to use your other measurement for your angle, which is radians. Okay? All right, how's that? Now, one of the big things that we like to use with right triangles, can anybody think of a specific theorem that we always like to use? Yeah, exactly, Pythagorean theorem, that's correct. So when you have a right triangle, you do have this relationship. Let me just make sure I spell it correctly here. I don't want to insult here. Okay, so it's c squared, it's always the hypotenuse side, is equal to a squared plus b squared. I want to point out the hypotenuse side is always opposite of what? The 90 degree angle. Do you guys see it? So your hypotenuse side is always opposite of the 90 degrees. Okay. So right triangles you can use, you have this relationship where c squared is equal to a squared plus b squared. Okay, now the last, so we know what a right triangle is. We have all that now, we get that. The next part we want to bring in is how our trigonometric functions come in. What are our trig functions and how are they related to a right triangle? And the good news is that all of your trig functions are related to right triangles. So we're going to go through, we're going to define them all in terms of this right triangle. There is a shortcut that you can use. I'm going to go ahead and list it called, you probably know this. Yeah, so I would say SOHCAHTOA, but SOHCAHTOA is probably more correct. Yeah, however you remember it is what we want, right? And we'll talk about this. I'm a math person, so don't ever take my pronunciations over somebody else's. That's probably wrong. All right. So what does that mean? What does the SOHCAHTOA mean? Okay, well, we're going to relate it to, I'm going to give you the first three main trig functions first. So let me make a little room here. And just so you guys know, trig functions, when you write them, they don't mean anything. Do you remember dealing with logs? You know, they're kind of awkward because ln doesn't mean anything unless you write ln of x or ln of 7. Trig functions are the same way. It's got to be, when you say sine, it is sine, but when you abbreviate it, the trig function doesn't mean anything until you put sine of theta, right? You have to have, so you're plugging in an angle, and then the trig function spits out a ratio. That's kind of how it goes. So the first one, the S, stands for sine, but we write sine of what? Some angle theta. Does that make sense to you guys? Okay. Now, how does the SOHCAHTOA relate? Well, the S obviously stands for sine. Now you have to ask yourself, what does the O and what does the H mean? The O means what? Opposite. And the H must mean what? Hypotenuse. So then what do you guess the A is? Adjacent. So if you know SOHCAHTOA, you're going to be able to get all your trig functions, basically. Okay, so sine then, if we follow this, sine says do OH. So it means go to your angle, wherever you've labeled that, go opposite of the angle, and then over what? The hypotenuse. So here's my angle. Are you guys with me? What's opposite of that angle? It would be B. Does everybody see that? So you would say, okay, sine is B, and then over what? The hypotenuse. And what's the hypotenuse? C. Do you see it? So it's opposite over the hypotenuse. Make sense? You got it? Okay. All right, next one is, let me make a little tiny bit more room here. Let's talk about, so we've covered all this. Check, we've got that, right? Now let's move on. Let's cover this. So C stands for cosine. That's your trigonometric function, cosine. And so we write cosine of theta. Are you guys with me on that? Now look, cosine is defined how? It means go to your reference angle. We know reference angle, or I keep saying reference angle. I haven't explained what that is. Just go to your angle, your acute angle theta, and it's saying go adjacent to it. Now adjacent, if this is my angle, adjacent means right up against it that's not the hypotenuse. Makes sense? So the adjacent in this case would be what? A, and then over H, correct, according to the SOHCAHTOA, H is what? The hypotenuse, and what's the hypotenuse? C. So cosine theta is going to be A over C. Make sense? All right, now we're to the last one. So we got this one. And we're to the T, and that's tangent. And so you write tan of theta is how you write the trig function. It is your only trig function so far. There will be one more that only deals with the legs. Notice the hypotenuse is not included at all. Do you guys see it? It says take O, which we know is what? Opposite, and put it over A, which is what? Adjacent. So opposite would be what? B. B, right, would be opposite, and then adjacent would be what? A. So it's going to be B over A. How are you guys doing so far? Everybody's got it? So SOHCAHTOA gives you what I always call the main three trigonometric functions. Remember, you do have to have a right triangle, though. All right. Now, I'm going to move over, and let me just redraw this triangle. We've kind of, actually, we don't really need it anymore. Let's go back and grab all this stuff. And now I need to talk about what we call the reciprocal functions. So all of these, and we know what reciprocal means. It means what? Flip them, right? So we just need to figure out what the flip is. What do we call the flipped trig function is basically what you're saying. So your reciprocals are all listed on page 521, but I'm going to go ahead and just kind of list them out here. And so your first trig function that we have is when you look at cosine. Its reciprocal is what we call secant. So just think C goes with what? S, kind of to help you remember. C with S. So cosine's reciprocal is what we call secant. And secant would mean you take and you go to cosine, and what do? You flip it. So you look at cosine. We know cosine is what? A over C. So what would secant be? C over A. Make sense? All right, now let's look at sine. Sine's reciprocal is called cosecant. So notice you have that what? CS kind of relationship going on again. Does everybody see it? The sine starts with S and the cosecant starts with what? C. So you're not going to line those up. It's actually opposites. And so you write it like this. This means cosecant of theta. That means you're going to come back over here to sine, and what are you going to do? Flip it. So what's cosecant going to be? C over what? B. All right, then finally, number 3, tangent has a reciprocal. And its reciprocal we call cotangent. So we write cotangent of theta. That means come over here to tangent and then do what? Flip it. And there they are. There are all 6 of your trigonometric functions. In order to define them, though, you need an angle. So you need your theta, and you need a right triangle. All right, if you don't have that, then your trig functions are not going to apply. All right, we have other things that we use, but we have to have a different relationship there. Okay. All right, all of this is in the text on page 520. If you want to go back to the e-text, I'm going to go ahead and give you just a couple of other relationships here. This is formally writing them out, and then I will show you a little bit more just so you can see it. Is everybody okay so far? This is crucial. You got to get this. Remember all this beginning stuff. Important. So nobody has any questions? Okay, good. All right, let's go back to the text. I'm actually going to move over to page 521. And the first thing I want to show you is the reciprocal identities. Now, you already know sine is related to cosecant. You know cosine is related to what? Secant. And you know tangent is related to what? Cotangent. You know they're reciprocals of each other. But so when I'm looking at this identity that they're using, I could write that a little differently. I could say sine theta would be equal to what? 1 over cosecant, couldn't I? Yeah. Right? And here I could say that cosine theta would be equal to what? 1 over what? Secant, right? Because that would be flipping it. And then I could say tangent would be equal to what? 1 over cotangent. So just so you guys know, sure you have those relationships, but you can change them around as you need to. Okay, so I'm going to give you a minute to copy all that. Let me give you a second. All right. Let me show you this. This part, I would like to come back and explain this part to you guys later. Right now, I just want you to memorize it. I promise you I will give you an explanation, but it makes better sense once we start moving into the coordinate plane and we start dealing with X's and Y's. And then you'll understand. You'll be like, oh, I get this now. But we haven't brought in the unit circle officially, and I haven't brought in the XY coordinate, so it's just hold on, it's coming, okay? So this part, just take my word for it, get it down, memorize it, and then I promise I'll come back and explain it. So tangent also has this kind of neat relationship with sine and cosine. Tangent is actually sine over cosine. Now, that's the only one you need to memorize. Because if you know tangent, guess what? How do you get cotangent? You flip it. So you get 2 for the price of 1, I guess. So you need to know both of them, but really if you know tangent is sine of theta over cosine theta, then you know cotangent would be the flip. So it'd be cosine theta over sine theta. So I'll give you a minute on those. All right, so the first question we're going to look at is, let's do question 15 in the book. And they're asking us, it says, find the value of the 6 trigonometric functions. Of the angle theta in each figure. Okay. All right, so we got to draw the figure. So this is given, you guys. They're giving us a right triangle here. They're drawing it kind of opposite of what we're used to. Bear with me, you know my drawing. All right, there's my right angle there. They're calling this 4. They're calling this length 2, and they're saying this is theta. And they want us to get all of our trigonometric functions, all 6. Okay? Now, the first thing that I'm looking at is I know to get the trig functions, I got to get the main 3 and then get the reciprocals, right? So I'm going to be using my what? SOHCAHTOA. I know I'm going to be using that. That'll get me the sine, the cosine, and the tangent. Are you guys with me all right? The only problem is that right here, I'm missing my length. Do you guys see it? And in order to get the trig functions, you need to have a completely filled in triangle, right? Because we wind up using all of it. So how do I find that missing leg? Pythagorean theorem, good. So let's call this maybe A temporarily. And we would say C squared would be equal to what? A squared plus B squared, that's Pythagorean theorem. Remember, the C is always the hypotenuse, which is opposite of the 90. Do you guys see that the C is 4? Okay, so it'd be 4 squared. A is what we're looking for, and B is going to be the other leg. So B would be what? 2. And then square it. So you're going to have 16 would be equal to A squared plus what? 4? So you have 12 would be equal to what? A squared. How do you get rid of a square? Good. Use your radical. Remember, for math, for everything we create, we can always undo it, right? So you take the square root. Technically, though, it is what? Plus or minus. This will come into play later. It doesn't matter here, but it will come into sometimes. And so here we have A is equal to plus or minus the square root of 12. Now, because you are talking about a length, and because right now we're dealing with acute angles, it's going to stay positive. Your triangles will stay positive because we're staying in what quadrant again? 1. But as you start moving around, that will change. All right, but right now, since theta is an acute angle, all sides are positive, right? In quadrant 1, x is positive, and what? Y is positive. Make sense? Okay, so you're going to say A is the square root of 12. Positive because we're in quadrant 1. And then you can break. Do you guys remember how to break 12? I know I'm being silly, but yeah, 12 is what? 4 and 3, so it's 2 root 3. Okay, perfect. So I'm going to erase the A now, and I'm going to put my 2 root 3 in there. Okay. Now that I have the triangle filled in, I'm actually just going to take that in my SOHCAHTOA and move to a new screen. Everybody okay with that? And then we'll just start filling them in. Okay, so we're going to start out with the SOHCAHTOA. We're going to do the sine part first. We need sine. What's the angle that they want us to use? They want us to use theta. Remember, that was in the instructions. And theta is where? It's up there. Do you guys see it? Now, the SOHCAHTOA says to get sine, you do what of theta? The O, right? What's opposite? 2 square root of 3. See how they move the theta on us? That's what I was telling you. Sometimes it's downstairs and sometimes it's up like that. Doesn't matter. Just find it. So it's going to be 2 square root of 3. And then over h, what's h? The hypotenuse, right? What is it in this case? 4. How you guys doing? Notice the 2 will reduce the 4 down to what? So you get square root of 3 over what? 2. Do you guys agree with me on that? Okay. All right, next trigonometric function we're going to look for is what? The cosine. We'll use the CAH of the SOHCAHTOA. So we're going to do cosine again of the angle that they want, which is theta. Cosine means the A stands for what? Adjacent to the theta. Do you guys see this is what's adjacent to the theta? So it would be what? 2. And then over h, what's the hypotenuse? 4. And that reduces to what? 1/2? How you guys doing? We're good? Okay. Then finally, we're on the tail end. So we'll do t, we know, is for tangent of theta. It's the only trig function other than cotangent that deals with the 2 legs. How do we do tangent? We take the opposite of theta, which would be what? 2 root 3, correct? And then divide it by what? The 2, the adjacent. Does that make sense? And so what are you left with? Root 3. Okay? All right, we have the 3. They want the 6. So now what they want us to do is remember all the reciprocal functions. So we got to come back. We know it's c with s. So for sine of theta, what's the reciprocal? Good. It's cosecant because it's c with what? S. So it's going to be cosecant. And all you do is you take sine and you do what? Flip it. So it'd be 2 over root 3. Now let me say this to you guys. I do not mind on the test at all if you leave it as 2 root 3. I know many years ago in math, I think it was just not nice to have the radical downstairs. It really doesn't matter to us anymore with calculators and stuff. But if you want to rationalize it, you can. You'll have to let me know what MATLAB is taking. I think it will take it as 2 root 3 now. It didn't used to, but I believe it will. But just in case, I'll show you how to rationalize it. If you want to get rid of the radical in the denominator, you would multiply the top and bottom by what? Root 3, which would give you 2 root 3 over what? Square root of 3 times square root of 3 is square root of 9, which is 3. Make sense? But I don't care if you leave it as 2 root 3, just for the record. Okay. All right. What's the reciprocal of cosine? I hear it's slight. Secant is correct. Secant of theta would be correct. This one's easy. You're just taking a half and flipping it. What would you get? 2. And then this one's always easy. Reciprocal of tangent is going to be what? Cotangent. So it'd be 1 over what? Root 3. But then, of course, if you guys want to rationalize, you would multiply top and bottom by root 3. And so what would you get? Root 3 over what? 3. How's that? Everybody's got it okay? All right. Okay, so we'll try to do at least 1 or 2 more. The next one we're going to look at is, let's do question 27. Everybody okay if I go to a new screen? Okay. For 27, it says use the definition or identities. We don't want to do the identities yet because I haven't given them to you, so I'm going to leave that off. So let me find the exact value of each of the remaining 5 trigonometric functions. Okay. This is the best way to do it anyway, guys. I need to explain this whole exact value thing too. Okay, so they're asking us find the exact value of each of the remaining 5 trigonometric functions of the acute angle theta. Remember, an acute angle theta means we're really in what? Quadrant 1. So everything will stay positive right now. That's basically what it means, right? Now, exact value. Exact value means that you all cannot write that cosine theta is 0.3333. You see what I'm saying? You can't write it like that. It's saying write 1/3. So don't use decimals. If you use decimals, it's going to mark you wrong. I'm going to mark you wrong on the test. So you want to make sure when it says exact, put square root of 3 or put 2 root 3 over 4, whatever it is. I don't care. But don't put the decimal in there. It means leave it kind of as the exact answer, okay? No approximating. All right, now, I'm a picture person. And to me, there's many different ways you can actually solve this that are much harder. The best thing to do is all of our trig functions are related to what kind of triangle? A right triangle, right? So if you draw the right triangle, you can get any trig function you want. Does that make sense? So what I'm going to do is I'm going to come over here to the side, and I'm going to draw my right triangle. You can put theta there, or you could put theta here, right? But I prefer to put it down here. That's just my personal preference, but you don't have to. And this is my 90 degrees. Are you guys okay with that? All right, you're going to use your SOHCAHTOA, of course. But you're going to start a little bit backwards because they've given you what? The cosine piece. Do you guys see it? So you're going to start filling in. Remember, you need a complete right triangle, right, to be able to go ahead and get all your trig functions. You need all your sides. So what you'll do is you'll fill in for cosine. Now, we know cosine says take the adjacent, right? And then over what? The hypotenuse. So this is the adjacent, and this is what? The hypotenuse. So your adjacent is what? 1. And your hypotenuse is 3. Remember, the hypotenuse is always opposite of the 90 degrees. How are you guys doing? Now notice I'm going to label that missing leg B. Are you guys okay with that? And then how do we get the missing leg B? To do what we did last time, which we used what? The Pythagorean theorem. So we know c squared is equal to a squared plus b squared, correct? So our c is 3, so we have 3 squared. A we know is 1, and then we're looking for that b. You guys doing okay? Yeah, so, 9, you're right. So he's saying it's 8 is equal to b squared. Do you guys see it? Of course, you would use square root property here. It is technically plus or minus. Why am I going with the plus? Because I'm in what? Quadrant 1. So your b is going to be square root of 8, which is really 2 root what? 2. Is everybody with me there? So I'm going to fill in over here 2 root 2. And now you have a right triangle. You can get any of them that you want, any of your trigonometric functions. It's completely filled in here. So now that I've got all this good information, I'm just going to go to a new screen. No questions? Everybody's okay? Okay. All right, good. Okay, so we already have cosine, right? Done. So I'm going to go ahead and next move to sine. Now, how do we get sine? What do? Take the opposite. What's the opposite? 2 root 2 over what? The hypotenuse, which is 3. Everybody okay with that? All right, let's get tangent next. To get tangent, we know we're dealing with just the 2 legs. You take again what? The opposite, which is what? 2 root 2 over the adjacent to that angle. So you're going to do 2 root 2 over 1, which is really just what? 2 root 2. All right, so we've got cosine, we have sine, and we have tangent. I'm going to do my reciprocals. Let me just switch colors. We'll do them in blue real quickly. And so the first thing, what's the reciprocal of cosine again? C with S. secant. It'd be secant of theta. That's all right. You guys are trying to learn it. All right, secant of theta. Is everybody okay with that? And so you would flip cosine. What would it be? 3 over 1, which is just 3. What's the reciprocal function of sine? Cosecant. So you would flip that. You'd have 3 over what? 2 root 2. If you guys want to rationalize, you'd multiply top and bottom by square root of 2. So you'd have 3 root 2 over, okay, you have the 2 from here, and then square root of 2 times square root of 2 becomes what? 2. So you have 3 root 2 over 4. All right? And then tangent's reciprocal function would be what? Cotangent. And it's going to be flipping tangent would be 1 over what? 2 root 2. Rationalizing if we want to. I messed that up. We would have square root of 2 over what? 4. Does everybody see it? Pretty easy. Nobody's lost? Everybody's good? Okay, good. You don't have any questions for me? Nobody? I just don't want you guys lost at this beginning level here, because it may be a beginning level, but it is, you have to get this stuff. So I just want to make sure we're good. Okay, I'm going to go ahead. I'm going to stop the recording.